Good afternoon, Code Talks. I'm very excited to be with you this afternoon to share about trunk-based development. During this session, we are going to try to address two problems that I believe are critical for building high-performing teams. First one is, how can we stop struggling with releasing software? And consequently, how can we deploy on Friday without freaking out? So this is the plan for the next 40 minutes. My name is Ludovic. I am working at NFQ. We are a company that is supporting customers to build products. We are operating in different countries. I'm myself working in Vietnam. We are hiring. In case you have any questions, feel free to talk to me after this session. When we start a project, actually, it's a little bit like the New Year resolution, right? We want to do things correctly. We want to set new process, new tool. We don't want to repeat the mistakes again and again from this last project that we got, right? And one of the structuring decisions that we usually take is to choose which branching strategy we want to have in the team. And this branching strategy will actually determine a lot of things, right? The way the team is going to collaborate together, the way as well we will manage the code stability because we will accept and refuse changes in some way. And finally as well, how do we handle the release management? So basically, when you choose a branching strategy, it will impact the team collaboration, the code stability, and the way you are going to release your software, right? A popular approach for branching strategy is Gitflow. It's highly popular, especially in the open source world, to kind of like manage contribution from people and to accept changes, to refuse the changes. And it's so popular that it has been used for so long in companies. The way it works, it relies on an isolation by branches. So you have a lot of long-living branches, right? You have the master branch in green. This is the main branch that will receive the stable version of your software. Nobody can actually commit anything directly on master. It's prohibited. Instead, you will work directly on the develop branch in orange. On a daily basis as a developer, you will work on this branch. You will submit your proposal, your change requests. And this develop branch will be the unstable version, the work in progress of the software. If we want to release a new version of the software, we will going to use the release branch in yellow. And in case there is a problem that we need to fix, we can introduce an hotfix branch, and we will fix the problem and merge it back to the rest of the branch, right? So when we use Gitflow, actually, we are using these long-living branches to isolate the code in different aspects and to control very specifically if we want to accept or refuse code changes in the software code base. Additionally, when people and teams are playing Gitflow, they also use it as a deployment strategy. Sometimes they will have these different environments, production, staging, QA. And for some reason, to deploy to this environment and to control the flow, they will use branches as well. So if I, as a developer, I want the QA team to test, I will push my modification to this branch. Then the QA will approve, we will move to staging and to main, right? So it may happen that we also have this deployment strategy that is kind of like coupled with Gitflow. So to summarize, with Gitflow, what we want to achieve actually is a code isolation, a strong code isolation by branches. We want to control the way we incorporate changes in our code base. For doing that, we are relying on long-living branches. And additionally, we may rely on branches to manage the deployment on my various environments. A couple of years ago, when we started a project, actually, we thought it was a good idea, right? We start with a team of like 5 people. And when we look at the metric at that time, it was kind of like okay for us, right? On average, it took us 1 hour to release a new version of the software, to pull the modification, to prepare the release note, to make sure that everything is okay, to deploy. On average, it was taking like 1 hour. In terms of changes in each batch, we had on average 50 changes, 50 commits. So it was kind of like reasonable as well in terms of impact whenever we release something. And we were able to deploy every week. As many of you guess, after time, the team grew and suddenly the metric does not look so great. Then you add more people. It starts to be kind of like concerning. And when you reach a situation where basically you spend a lot of time to release, you start to ask questions, right? With like 20 people, it took us 9 hours just to prepare a release. 1 person in the team was dedicated to handle the conflicts, to merge everything, to make sure that everything is checked, to prepare the release notes. And on average, we had a lot of changes in each release batch, and we were not that able to deploy that frequently. So when you look at this metric, you ask, what is happening actually? You add more people, but basically you release less frequently than before, despite you have like a huge team. So what is happening? Basically, we face a situation called the merge hell, right? We spend a lot of time to handle conflicts because we have so many branches. Everybody is working on something different. We have to handle the conflict management. We have to merge back. Somebody fix something. And then we need to pull as well to cherry pick this modification to solve locally the problem that we have. And we have this situation that, yeah, it gets a little bit like complicated. Everything is going everywhere, and it's a little bit like frustrating, right? Because you spend a lot of time to fix conflict rather than investing time on building your software. This situation exists because actually when you do Gitflow, you don't do continuous integration. No matter if you have a CI server, it's not because you are using Jenkins, GitHub, GitLab, Circle CI that you are doing continuous integration. It's completely unrelated. When you do Gitflow, by definition, you are not constantly integrating the modification of the code for the simple reason that you are having long-living branches. So you delay the feedback in which you will have a complete overview about every modification that is done. If we look at this picture, it's like you have a team that is working on the same car and everybody has a vision about the modification we are putting in the car. In Gitflow, it's just impossible because everybody is working on different branches in different life cycles. So you are never continuously integrated together. You are always delaying somehow the day you will actually be together. And this is why we have so many conflicts, right? Additionally, we had a lot of lead time. Because we have different environments that were kind of like mutualized between the teams, the production, the testing, the development environment, people had to wait, right? They say, hey, look, you are using this environment, then I cannot do anything, so I will start a new feature instead because I don't want to lose my time. But because you are doing that, you are expanding the life of the branches, meaning you will work today on something new, but in the meantime, your modification is still open. You still have to maintain this extra branch that nobody's working on. So it increased the lead time and it increased as well this merge shell as a consequences. And why do we have that? Because we have no continuous deployment. Again, when you do Gitflow and you use Gitflow as a deployment strategy with branches, you are actually not doing continuous deployment. It's just impossible because you are isolating your environment through branches, meaning you will still have to manually merge, approve, handle the deployments. So there is no way it can be continuous. So now, how can we solve that? How can we avoid a situation in which every merge is like crazy? It's like the war, it's like conflicts. How can we solve that? One way to solve that is to take a slightly different approach, a different branching strategy, which is called chunk-based development. It's not very new. It's actually an extreme programming approach. And it's something that is used by high-performing teams. The principle relies on the following. We are just using a single branch called the trunk, or the main, or the master, and that's it. Basically, there is no develop branch. There is no release branch. There is no hotfix branch. everybody is working directly on the trunk. Everybody is able to work directly on this trunk, and the trunk becomes the only stable version to be released. Meaning the trunk is actually your release. Every time you deploy to the trunk, it will be deployed automatically to production. You remove all the steps. Of course, we tolerate short-lived branch, meaning you can work not directly to the trunk, but you can have your own feature branch, and you can merge back to the trunk where you are done. However, you can only do that by having a short-lived branch, meaning you have a branch that only can last one day. At the end of the day, you have to merge back. So let me recap the principle. In trunk-based development, we have this trunk. In this trunk, we have a single point of truth. Everybody is working on that. We stop isolating the software in various branches. The second point, the trunk should be resiliable all the time, meaning the trunk becomes the stable version of the software that is your production. Additionally, for the branch, we only accept short-living branches. It means that we merge all the branch at least one day back to the trunk. Okay? So how do we implement that, right? It's kind of like just a set of principles, but how can we implement that? We need to start first by having a series of like small incremental and consistent changes. Basically, every commit becomes a release. We stop releasing a bunch of tickets. We stop releasing a bunch of PRs. We stop releasing a bunch of commits. Every time you commit to master branch, to the main, the trunk, it becomes an atomic release that will be deployed to production. This is exactly what it means. Additionally, we will only accept short-living branches, 1 day maximum. It means that if you open a branch in the morning, in the afternoon, it has to be merged back to the trunk. Why? Because you want to give visibility, transparency about what you are doing in terms of modification, so everybody is constantly aware about what is happening, and we reduce the conflict, right? You may say it's a little bit weird, right? Because in case I have like very long work to do, how can I merge back to the trunk, right? This is something we are gonna see in a couple of minutes. By using feature flag, we can wrap actually the unfinished work. I will explain that in a couple of slides. A couple of recommendations about how did we approach that. Basically, it's a very like critical mindset shifting, right? For years, you have been told that you can't directly commit to master, nobody touch master, we don't release from master, but from the release branch, and suddenly it's a little bit like open bar. We can do whatever we want. So it's a little bit like a very like strong mindset shifting for the engineering team. Additionally, they need to be aware about the commit size, the story size. As well, it has to be discussed in workshop. So when we deploy this approach, actually, we run a lot of workshops to explain what is a big commit, what is a small commit, what is the story size, how do we define, where do we start, where do we stop. It has to be discussed and agreed within the team. Otherwise, it will be very hard to achieve. Additionally, you need to spend time to instrument and adapt your code review. I highly recommend to abuse about pull request decoration, meaning automate as much as possible some steps directly in the pull request process, and to encourage synchronous code review. Why? Because you need to merge back every day to the trunk, your code needs to be reviewed. And your colleagues cannot say, hey, okay, just send me a message and I will look later. It's not possible. You have to sync together, and so that every day we can merge back a satisfying code back to the trunk. So you need to move to synchronous code review. You need to dedicate a little bit of time during the day to align and to review the code. Additionally, you need to consolidate your build process. You need to have a pretty strong test suite in terms of completeness, a good coverage, and it needs to execute fast. For the simple reason that basically, since you will merge very frequently, and since you remove the branches that in the past was protecting your code, then you have to engineer this process of pull requests. And then you have to automate as much as possible. Okay? The benefit of that, after we achieve that, is, of course, we have a lower merging effort. we are moving the problems much earlier than before. It's not about like merging 2 weeks or 3 weeks or a month later. It's about merging directly and handling these conflicts from the beginning, which is much easier. It also allows us to increase the release frequency, to have much more stable iteration, because you are releasing a single commit per release. The change is very small. You stop deploying a series of tickets, you stop deploying a series of commits. Therefore, the modification is such small that it's much stable for the software to detect when you have some issue and also to roll back if you have a problem. Finally, it helps as well to develop baby step approach for the teams. The teams start to strategize. They start to act in a step-by-step approach. We can start with a small modification. It will be deployed automatically. Let's see how it goes, and then I can carry on. So it kind of like structure a mindset in which we think into individual steps rather than starting a big refactoring, starting a big component that will take like 2 or 3 weeks. So for this reason, the trunk-based development approach helps us to achieve this kind of like benefit. A couple of minutes ago, I was talking about like, hey, we have to merge every day. And it means that we will merge in progress work. We will merge back to master, to the main, to the trunk, a feature that is not finished. How is it possible? How can we accept that? A way to do that is to use what we call feature flags. A feature flag is a mechanism in which we will wrap our piece of code inside a condition, inside a big if you want. How does it look like? Let's have an example. We have our front-end development team, and they're working on a component. For some reason, the backend API is not ready yet. So instead of waiting and starting a new ticket, they will deploy it directly. They will merge it to the trunk. They will wrap it inside a feature flag. And when the backend team will be ready, we will be able to enable this component, and it will be rendered. Okay, so it means that basically, when I have finished my work, I can just like merge back to the trunk, wrap this modification inside a condition. And when the rest of the team is ready, we can just like turn it on, and later on, remove this feature flag. It works a very similar way in the backend, right? I am working on a very complex algorithm, and for some reason, I'm struggling a bit, but I still want to show to the rest of the team the modification I'm doing to avoid that among this team, somebody is kind of like modifying the same file or is trying to do something that has an impact. For the same reason, I can wrap my code inside a feature flag until I finish my new version of the algorithm. And by doing that, I provide transparency, and I am able to modify the code base without having a big difference between my working copy and actually the trunk. We can use as well that to have a product mindset, to target a specific audience. I'm living in Vietnam, and a couple of months ago, I was in Da Nang. It's a very beautiful city in the center of Vietnam. You have like nice beaches, you have like a very nice city. And when I was at that time, I actually ordered via Grab a taxi. Okay, Grab is the equivalent of Uber. And I was in Da Nang, I actually notified that they were actually using a feature flag. They were enabling a feature only on that city. And because I was ordering a taxi, I was able to see this feature. But if I was ordering a taxi in another city, I would have never suspect that this feature was about to become live. So basically, we can also use feature flag to target some audience, to enable some component, some function, depending on the audience we want to target. And then it's kind of like become very interesting. We are able to have a product mindset from the development phase. We are able to release by targeting a specific audience and reducing the risk. So feature flag can be used as well for these purposes in the same context. So to recap, feature flag allow us to deploy non-ready feature to production. Just like you may have like work on the roads, the road is still like accessible, but with feature flag, you are kind of like deploying this feature to production, but they are not enabled. It's very important to understand that features are enable and disable on runtime. It means that in case something goes wrong, I can instantly deactivate this feature without having to change the code. So it means that I can recover much easier, much faster, much quicker in case there is an issue with one feature. So we can have this enabler feature on the runtime. Additionally, we are actually decoupling deployment from release. When we do feature flag, we deploy all the time to production, every day to production, but we are maybe not releasing the feature. Every modification in push constantly to the production, but the feature is maybe not enabled. The feature is maybe not available. So in the past, whenever we were deploying to production, it was actually a release. Nowadays, we are deploying every day, but maybe we are not releasing every day. It's a very big change in the approach. So how do we implement feature flags? Basically, we can have a custom implementation. We can use like very low-tech approach, environment variables. We can use libraries. There is plenty of libraries in various languages to support this. We can implement our own component because at the end, this is not really rocket science. What we need is a databases. We need to store a series of like Boolean states. And we need to have a service allowing to expose this capability for my system. We can rely on some SaaS solution. I have listed some of them as well. Which one to choose? It will depend on your use case. If you want to have a very product mindset approach, probably the SaaS solution will allow you as well to do some A/B testing, to couple and to have some very like fine-grained triggers. If you really want to use feature flag for a pure technical approach, maybe it's better to go with custom implementation like a library, for example. It's interesting to note as well that we can integrate feature flag in our software development lifecycle. For example, in Jira today, you can visualize your feature flag, and then when you deploy something, you can actually pilot, you can actually manage that. And it's kind of like interesting because it provides transparency directly for the product management team. They don't have to call you to say, hey, where are we with that? Can I turn myself on and off this flag? How can I manage that? So we are also offering a lot of options to the product team, and it's very interesting in terms of value for them. A very frequent question is where to place feature flags. Should we put that in the user interface, in the front end? Meaning I will put that on the component or in a page? Should I put that in the API, on the payload, the endpoints? Should I put that in terms of like business logic, meaning like in very like deep service to conditionally manage discrete processing? This question can only be asked depending on the feature you want to implement. For some feature, of course, the backend is super important because you will have to handle some specificities, some business logic that are quite specific. So it's really depend on what you want to achieve. But a good word is to kind of like put as high as possible. We don't want to have feature flag inside another feature flag inside another. Ideally, we should cover a widespread area and we should not overlap. When you implement feature flag, you will need to think as well about two aspects: the security and the testability. It's not because you are hiding a feature that nobody can use it. You have to make sure as well that the API is actually validating that someone can use or not this feature. So hiding is not enough. We need to make sure that the people that are allowed to use this feature are actually checked, valid, that we still accept valid values. You are still pushing code to production despite not enable. You have to consider the security aspect from the beginning because this is very important. Additionally, you need to test your feature flag. You need to have a series of unit tests to validate that the feature flag is working when it's enabled and it's working when it's disabled, that we have the expected behavior. If you are not doing that, you are taking a lot of risk, and basically you will kind of like fragilize your system and make it like less robust, and you will lose interest of the flexibility of the feature flag. So basically you will introduce technical debt if you don't pay attention at the security and the testability approach of the feature flags. All right? Feature flag as well can go completely wrong. There is a famous like use cases from a company in the US. It was like a trading company. They implemented some trading algorithm on the US stock exchange. And roughly 10 years ago, they implemented a system and they heavily rely on feature flag. The little problem is that they recycled an old feature flag, which is basically an anti-pattern. What happened actually is that there was a new regulation in the US, and then they kind of like modified the algorithm, and they did that pretty well. They were very professional. They test the feature flag, it was documented, they double check it, they deploy it. The small problem is that they forgot one machine. They have like 8 servers, and they deploy the new version of the code on 7 servers instead of 8. And unfortunately, they recycled an old feature flag. And when they turn it on, the last machine that did not receive the new version of the software actually enabled an old feature flag. What happened is, like, in 45 minutes, this machine made a lot of like very weird transaction orders that cost up to $400 million. So you can imagine that this is kind of like a huge mistake. Of course, the company just like shut down in 48 hours because they didn't have any cash inside. And just because of this mistake, this is to realize that, yes, feature flag can go wrong. Even if we test it, even if it's documented, even if it's secure, we need to consider this aspect as well. So a couple of recommendations with feature flag. We need to use them as little as possible. As little means it needs to be manageable. Those 50 feature flags are manageable? I'm not sure. Those 20 feature flags are manageable? I think it's okay. It really depends on the team and the isolation you have in terms of like segregation per teams. You need to place aim as high as possible, of course. They need to be battle tested. There is no way you can release a feature flag if you have not tested it. It's just like impossible. They need to be documented. We need to understand what is happening when the feature flag is enabled, what is happening, what is disabled, who is responsible, when do we remove the feature flag, and who is responsible to remove it. This is what we call documentation. Additionally, we need to remove them when it's finished, and we should never, never, never recycle them. Okay, so we can't reuse them. Once they're finished, we just drop them, we forget about them, we introduce a new one, and that's it. Okay? So, a benefit of using feature flag, we have reduced the cross-dependency between teams. People stop waiting for each other. Hey, I'm waiting for the backend to finish. Hey, I'm waiting for the frontend to finish. Hey, I'm waiting for the QA to be available. We stop doing that. When people are available, they can actually like work on that. We managed to enable continuous integration because now with trunk-based development and feature flag, we are able to do that. We constantly visualize the modification happening in the code. And we start to adopt a product research mindset, meaning we are able to have feedback through small iteration. Okay? So now I would like to end with how did we solve the problem of productivity with feature environment. One of the problems we have with as well the Gitflow was that each environment was actually managing by a branch. So the situation is the following. In the past, we have like 3 environments, and the team were kind of like using the similar environment because the deployment model was coupled to the Gitflow model. And of course, it's not great because you have basically a traffic jam, you have a bottleneck. The way we solve that is that we have reused the trunk-based development approach, and this time we decided to create ephemeral environment per branch. What does it mean? I am a developer, I'm working on this branch. What I'm going to do before merging back, I will instantiate a feature environment. This is something that we have created, meaning I will have my own version of the backend on the front end, of the crons, of the queue, of the databases. I'm not sharing that with anyone. If another developer is working on another branch, he's able as well to initialize his own environment, and again, it will contain the backend, the front end, the crons, the queues, the databases. The way we do that, we rely on Kubernetes. Okay, it's a container orchestrator, and basically what we are doing is that we are creating a namespace, and inside we are deploying a series of containers that represent the branch that we are actually working on. And we can access this environment by a dynamic URL. Basically, we use this convention about using the Jira ticket ID. So we have a Jira ticket ID, and then we use this to kind of like access the URL and the environment. So we do that, and every time we have a new environment, we basically spin up a new environment. Okay. The tricky part when you do that is how do you build environments? So basically, you have a feature. We will call, for example, Jenkins. And basically, we use the naming of the pull request or the branch name to actually target the modification we want to pull. I give you an example. We have a series of repositories, the backend, the front end. Let's imagine we are working on a ticket, on a feature. And we want to pull the modification across different repositories. The way we do that is by labeling the pull requests or the branch. It means that, for example, I am working on the feature number 1, and on the feature number 1, I'm only modifying the backend, because this is only where the modification should be. Then, there is no branch corresponding in the front end. As a consequence, when I will build my feature environment, I will fetch the backend feature 1, and I will work with the master. Of course, if I am working with colleagues, and for example, we have to modify the front end, my colleagues will open a pull request, feature 01, and then in that case, instead of having feature 01 plus master, I will have feature 01, feature 01. This is the way we can handle cross-dependency, cross-repository, and still build a consistent environment. The second aspect that is interesting is how do we launch an environment. We have coupled our system to the Jira ticketing system that we are using. So for example, we want to reduce as much as possible the manual effort of the development team. It means that, for example, I'm working on a ticket 01. When I will shift it to testing column, automatically we will create an environment. It means that Jenkins will actually build this environment, deploy it on Kubernetes, and he will notify the creation of this environment in the Slack channel, plus on the Jira ticket with the URL of this environment. I will work for like maybe a couple of minutes, a couple of hours. Maybe I will use that to demo to the stakeholders. Maybe I will involve the QA team. When it's finished, I will move it to ready column, and then the environment will be destroyed. Okay? So it's kind of like very important to think about that, how people are going to use this system, how we remove the complexity. Okay? So a couple of recommendations. Of course, when you do that, you need to monitor your instance creation to be cost effective. Because when you do that and you have like 20 people working, if everybody is kind of like running an environment, the cost is pretty high. So we need to also, from the beginning, implement some alerting, some thresholds, remind people to close their environments, maybe to have some levels. The way we achieved that actually on our own was very simple. You can see that here we have a red flag. It means that, for example, some tickets, we never need a feature environment. Then we don't have this label. And then when I will transit to testing column, nothing will happen. So this way, we kind of like say, OK, if you need it, you just place this label on the Jira ticket. If you don't need a feature environment, you don't have this label. OK? So be cost effective is quite important. The second important learnings is to leverage production data to provide relevant data sets. I give you an example. If you spin up an environment, you can have like fake data, but it will not be as good as using production data that you anonymize. So what we do actually, every night we are pulling production data. We anonymize completely the databases. We take, for example, like 20% of the databases, and it serves as a sample for our feature environment, meaning that when we spin up an environment, we have a valid data. We have business objects. We have things that make sense and that help us to reproduce a bug, to make a relevant demo, to test a feature, without spending time to kind of like assemble a lot of like test cases. And finally, like I mentioned, we need to have this self-service approach with platform engineering. Okay? A couple of benefits. We remove the bottleneck. Okay? It's been completely removed. The ownership increase in the team. People were much more responsible because now they can just like deploy easily some environment, so it's much more easier. We have more transparency, easy to do some demo, so the stakeholders feel more involved. We don't have to say, hey, wait, I need to deploy that somewhere, and by the way, it's not working. And finally, when we implement our end-to-end test, it was very easy because the end-to-end suite was targeting directly this environment. Okay? So I need 2 minutes to finish. Couple of summary. Before Gitflow and after Gitflow moving to trunk-based development, we managed to increase by 3 the number of release in terms of frequency, right? The first month, we were able to do a couple of release per month, and moving to trunk-based development really helped us to improve that, right? Couple of numbers. On 1 week, we were able to deploy 13 times. On the top day, we deploy 6 times on that day to production. And on average, we have a defect rate of 7%, meaning of 100 release, we only have 7 that have an issue and that we were able to roll back very easily. Okay, so a couple of numbers that we always need to keep track on: release and the defect rate. Okay. The challenge I already mentioned. How do you manage the engineering mindset changes? What is the definition of ready, the story size, the dependency? It takes time. We need to encourage the ownership among the developers. Suddenly, you have to manage the master branch. Suddenly, they can deploy directly to production. It's not something that they are very far away, so we need to encourage that. We have to rethink as well the way we organize our teams. The team structure can be affected, right? In the past, we were working a lot with component teams, and now we are mostly working in feature teams thanks to this kind of approach. Couple of recommendations. We need to support the adoption by having workshops with everybody, including stakeholders. Suddenly, you deploy faster, the feature is ready. We have to remember them that we need to remove feature flags, that there is an extra cost. Maybe not today, but in 1 or 2 weeks, we will need to work again on this feature, despite it's working, despite it's available. So we need also to educate the people among that. Yes, we move faster, but we also need to pay back at some point the feature flags integration. We need to challenge the sprint plannings to remove dependency, to refine the scope of work. Always think about smaller chunks. How can we remove that? How can we have a small scope? We need to constantly monitor the trends, the time, the defect, the automation, conduct retrospective, because we have to follow up with this transition. And finally, we need to encourage developers to ship autonomously. So for example, today in our team, when a new developer is joining, he has to deploy to production on his own at least 1 or 2 times in the first week. Just for him to understand that it's not dangerous, everybody can do it. And at the end, all the developers are much more happier. They have a direct control on their destiny. They can visualize the impact of their work. And they are way much happier than before when they were just okay, I finished this feature. Somebody else is going to validate. Someone else will deploy it. They are losing this feedback loop that makes sense for us as developers to work on. So they can visualize the value and the impact they provide, and I think it's a great benefit. So is trunk-based development suitable for me? 2 questions to answer. If you're working on a product development and you are focusing on having quick release, you want to release fast, you want to have a very reduced time to market, yes, definitely trunk-based development is for you. If on the other hand, you are working on a software development, when you don't really matters the release frequency, but instead you really want to control exactly the version, the software, you want to control actually that, maybe trunk-based development is not suitable for you and Gitflow still is a good option. Thank you very much for your attention. I will be very happy to take a couple of questions.